Let's look at some modelling with trigonometry. Example 1, the depth of water d meters in a harbour on a particular day is modelled by this formula, where t is the number of hours after midnight. Boat enters the harbour at 6:30 a.m. and it takes 2 hours to load the cargo. The boat requires the depth of the water to be at least 3.8 metres before it can leave the harbour. Part A, find the depth of the water in the harbour when the boat enters the harbour. So for part A, we know the boat enters the harbour at 6:30 a.m. So that means t is 6.5. Because t is the number of hours after midnight. All we need to do is sub that t value into the d formula. Make sure we're in degrees because there's a tiny degree symbol there. And in the calculator, that's 4.482 or 4.48 to 3 significant figures. And in modelling, we should also give the unit, so that's in meters. There we go. So that's the answer for part A. Part B, find to the nearest minute the earliest time the boat can leave the harbour. So it said that the boat requires the depth of the water to be at least 3.8 before it can leave. So let's find out the time when d is 3.8. To do that, we'll just set d equal to 3.8. So 5 plus 2 sine 30t equals 3.8. And we'll solve that for t. So just rearranging here. First solution for 30t, when we do inverse sine of minus 3/5, is negative 36.87. Now, originally it said t had to be between 0 and 24. So if we amend that for 30t, we know that we need it to be between 0 and 720. So that means we'll need to look for some more solutions here. I usually use a graph. There's sine, negative 3/5. Lots of potential solutions here. First one is here. That's our negative 36.87. The next one along, I'll do 180 plus 36.87 and I get 216.87. Now to get t, we need to divide these values by 30. And when we do that for 216.87, we get 7.229. So around 7.229 hours after midnight. That solution won't work in this context because it said that the boat takes 2 hours to load the cargo after 6:30 a.m. So we need the value of t to be at least 8.5. Therefore, we'll go ahead and look for the next solution, which will be 360 minus 36.87, and that's 323.13. When we divide this answer by 30, we get t is 10.771, which will work in this context because that's 10 hours and 46 minutes. So the time will be 10:46 a.m. And that works because the boat then has enough time to load its cargo. So with modelling, just be really careful. Go back and read the context of the question to make sure your answers make sense. Example 2. Part A is just asking us to express 10 cos theta minus 3 sine theta in the r cos theta plus alpha form. I have made another video on this, so you can go ahead and check that out if you haven't already. So part A is nothing to do with modelling really. It's just a classic case of turning that expression into a different form. To do that, we expand r cos theta plus alpha first, using the formula book is this. And then we do a spot the difference. So they've got a 10 here. We've got r cos alpha, which means r cos alpha is 10. They've got a 3. We've got r sine alpha. So r sine alpha is 3. To find r, we do square root of 10 squared plus 3 squared, root 109. And alpha is inverse tan 3 over 10, which in this case, 16.70 to 2 dp. Therefore, 10 cos theta minus 3 sine theta is equivalent to root 109 cos theta plus 16.7. And that's our answer to part A. Now, part B is where the modelling comes into it. We've got a Ferris wheel, and it says the height above the ground of a passenger on a Ferris wheel t minutes after the wheel starts turning is modelled by this equation. Figure 3 shows the graph of h against t for 2 complete cycles of the wheel. Then it says, given that the initial height of the passenger above the ground is 1 metre, find a complete equation for the model. So basically that's asking us to find alpha. Now the trick for this is linking part B back to part A. Part A might seem a little bit random at first, not related, but it definitely is. Do you notice that this part of the model is basically the same as this? That's the link there. So if I wanted to, I could write h equals alpha minus n cos ATT minus 3 sine ATT. I've done that, I've factored out the minus so that it will match exactly inside the brackets here to what we had in part A. Because then I can just replace that whole bracket with root 109 cos theta plus 16.7. The only difference really is instead of theta, we have ATT. this time. So that's the new model. Now to find alpha, we can use that information about the initial height being 1 meter. So when t is 0, h is 1. You could sub that into either model. I'd probably use the original here. So 1 equals alpha minus 10 cos 0 plus 3 sine 0. When you work that out, alpha ends up being 11. So the complete equation altogether is now h equals 11 minus root 109 cos 80t plus 16.7. That's the answer for B part 1. B part 2, find the maximum height. Now that we have the model in that format, we can easily find the maximum height because we know the behavior of cos in general. In general, cos will have a maximum of 1 and a minimum of -1. And that's all you really need to use here, because that means that the maximum height will be h equals 11 minus root 109 times -1. That's the way to get the biggest value of h possible. And I'm using -1 rather than +1 because there's a minus here, so then minus minus makes a plus. Altogether, the maximum height would be 11 plus root 109, and that's in meters. That's it for now. If you found this video useful, please do remember to like, comment and subscribe to my channel if you haven't already, and do share this with anyone else you think might find it helpful. Thanks, and see you next time.